Hey everyone, welcome to the Immutable and Reproducible Software track at scale 21x. The next talk is going to be by Pietro DiCaprio, and he's going to talk about immutability and atomicity in Linux. And with that, please welcome them and take it away, Pietro.
Hello, hello, can you hear me? Thank you for being here. I'm Pietro DiCaprio, and I'm a developer in the VanillaOS project. I hope someone here heard about it. Yeah. For those who don't know what I'm talking about, VanillaOS is an immutable Linux distribution. The first version we released was based on Ubuntu, but version 2.0, which beta has been released at the end of January, is based on Debian with a full rewrite of our tools for immutability. Indeed, we changed a lot of stuff. Today, we are not really talking about VanillaOS. We are talking about the concept of immutability. What is immutability, and what means for a system to be mutable, and why it should be mutable. So let's start from the problem affecting the systems that are not immutable. Basically, most of the systems out there. The issue is that when you make changes to your system, for example, you install packages that may have dependencies from other packages, you don't have a certain state of the art. You can't really predict what are those changes doing to your system, and you can't really predict the final result. And since all those changes are independent to each other, you can have a situation where your system doesn't perform as you expect, or your applications don't run as you expect. If we consider our standard Linux installations, we install something, this has a dependency, a specific version of the dependency, everything works well, then we download a system update, or simply we install another application that has a different version of that dependency as a requirement. The installation will change that dependency, but then what happens to the app we installed earlier? It may work, it may not work. So this is a problem that affects basically every system we have. And side note, this is not completely fixed by immutability, but is fixed by a mixture of the options we have to manage our system. So what means immutability? What means for a system to be mutable? It means that the changes of your installation of your core system cannot be performed directly. You cannot simply change a driver, a kernel module, whatever dependency you have to run your system as a whole. Indeed, the file system is read-only. You simply cannot write to it. To perform changes, you have to run a transaction, and we are going a bit deeper into it soon. We bring to the table also atomicity. Atomicity, maybe some of you is familiar with SQL when you run transactions. When you run a transaction, is all or nothing. If you have any error during the process, everything is rolled back and you have no change at all. So an atomic update to a system is or the installation of everything you're installing, every update, new package, update package, whatever, exits properly with success, or everything is rolled back and you don't have a half state of the art where something has been updated, something is not. Maybe your system still works well, maybe it's not. I believe let's ask to how many of you happened that an installation or update process didn't success, and then you had problems with your system?
Not only yes, but I've had people call me in to fix the result.
So but probably everyone in the room raised the hand, or if not everyone, like 9 out of 10. So you feel what I'm saying. You really understand what I'm saying. And well, an atomic transaction would, let's say probably, but I'm confident we don't need the probably word in front of it, solve this issue, because you can't leave an uncontrolled state of your installation. So how all of this solves the problem? Mainly with two method reasons. If you ensure a state of your system, you can be quite safe that nobody is going to call you to fix the problem. And a defined state means also that your system can be reproduced in the exact same way. So if you have someone that raised the hand saying, I have a problem, something is not working, if you have a defined state of the art, you can replicate the same installation and have a copy of that environment to work on without worrying of breaking maybe a production environment or a user environment. And you can understand the problem, solve the problem, and create a patch that can be applied on the user system that will provide exactly the same result you tested in the test environment. Moreover, since immutability requires a read-only file system, you prevent changes to the critical components of your system, reducing a lot the risk of systems that have been changed and broken by mistake, by maybe even without knowing that something was happening. Many times happens that updates are downloaded, are installed, you reboot your system, the new whatever is loaded at system startup, and you find changes you were not expecting because something happened during the 2 boots of the system. So, based on what we just said, Atomicity plays a crucial role in all of this. Also about replicating the fix. So if you have to deploy your fix in multiple machines and you want to be sure that everything happens as you expect, what you need is atomicity. You need an initial state, a transaction, and a final result. And you must be sure that this transaction happens in exactly the same way on all the systems you are affecting. So, again, you don't solve all the issues with one feature, one method. You have to make a mix of what we have. Immutability with atomicity, and maybe a set of tools depending on the distribution you're running, on the goal you want to reach. So, let's talk about 3 implementations. We have AB root, that is what we, Vanilla OS team, created. We have OS3 that probably most of you know at least by name. And we have Btrfs, that is a wall file system that provides those key features. AB root has been inspired by Chrome OS, basically. You have 2 main partitions that are one the copy of the other. And those partitions are containing your entire operating system is the core of your computer. When you install an update, you are not installing it on the partition you are currently running, since we said it is read-only, but you are applying it on the partition that is currently offline, that is not used, that is in write-read. Once the transaction is completed and the changes are actually written on disk, because before the transaction exits, nothing is written. Once the changes are written on disk, you can reboot your system. Then reboot, we are back on Windows style, where you reboot your computer to apply updates. But for the good of it, you reboot your system. You don't really know, but you are changing partition. You are running the one that has been updated, and you have your updated system with two key points. The updates were installed successfully, because otherwise they would not be installed on disk, and the partition would not be changed. And second, you still have a point back possible to the other partition if anything doesn't work properly for whatever reason. And you can replicate what happened, because you can provide to your manager or help desk or whatever the information of what you're running, and you have a real state-of-the-art available to be replicated. This is an example of how an AB root disk would look like. We have the two root partitions, indeed. Side note, on AB root version 1, you needed actually two partitions of 20 gigabytes dedicated to each of the root partition. But from 2.0, we use LVM team provisioning, so you don't need to dedicate 40 gigabytes of your disk to AB root, but it's more elastic. And in the immutable systems, all the data that the user is actually needing about the system, like configurations, preferences, auto startup applications, all that kind of stuff, it's saved in the user data, in the user space. That is not mounted as read-only, of course. When you install apps, those are not installed in the root partition. Those are installed in the user partition. So those are consistent between root partitions and are not affected by the switch. You switching partition, you don't get the older app, or you don't need to have double the space because you double install an app on the partitions. Those are shared. What is replicated is the system, what you need to run your computer. So, of course, there are ways to have also your data replicated, but the question is, does it make sense to occupy double the space? Maybe a backup somewhere else is the best option for replicating your data. Because otherwise it will be like a RAID 0 or RAID 1 of your disk, but RAID is not a backup, as I hope everyone knows. So don't make your data immutable, make the system immutable, and back up your data somewhere else. We mentioned OS3, that is used by, for example, Fedora Silverblue, uBlue, and Endless OS. It manages your installation like a Git repository. So it has a tree of the state of your installation, and every time you perform a transaction, a new commit is created, and you can check out those commits and navigate through the states of your installation. You can create branches for testing and go back. You can do a lot of stuff really Git-like. So if you think about a repository, you basically can do it with OS3. Of course, you can't have as much as fun as a code repository because you're talking about your system, but you got the point. But RFS instead is it's used by projects like MicroOS and AstOS. The file system itself includes snapshots and rollback capabilities and has transactional updates. So as you can see between all the implementations, the concept at the base of it is the same. You don't directly touch your core system. You keep a safe copy of it, and you apply changes in a controlled environment via a transaction. Transaction that can be atomic or not. Not everyone is implementing it as an atomic transaction, so it's something you should check when choosing this strategy. And at the end of the day, what you have is a safe managed system, or kind of. And you can be sure your system runs always properly. And usually I got asked, why should I have an immutable system? Why should I use it in my daily laptop? Maybe I have a backup of my data and I don't care about losing it. Well, it's not only of losing, it's not about losing data. It's about losing an entire installation. It's about losing your main environment. How many in this room are software developers? Okay, and who uses the computer just for emails and kittens on YouTube and stuff like that? Okay, so who didn't raise the hand as a software developer? Now I'm curious to know what he does. Just work stuff, emails, documents, stuff like that, or? Okay. Yeah, so if you think about your system, let's say that you want to be sure it works when you need it. Even if you have the backup of your data, even if you know how to set up again your system, the point is not needing to, not being worried about installing updates, about testing new stuff. And if you think of this concept outside of your laptop, and you bring it to the servers, to production machines around the world, maybe in plants of your customers where you don't have direct access. And if their machines, the production machines, machines also in the meaning of not computers, but computers in manufacturing machines that are handling metal or clothes or whatever, or medicines for the safety of people, if those machines are blocked because your system crashed, because something happened as an update, or simply a failure of the system at runtime, well, that's a problem also in matter of responsibility and cost. Providing to your customers a safe system to run the business, it's something to think about. And we see this daily as system failures, as productions blocked by some kind of failure, server side or local production side. With an immutable system, what you usually need is just a reboot. If the disk didn't fail completely, and that's another story, you don't save it with immutability. If the disk didn't fail completely, with a reboot, you can continue to produce, and meanwhile, the IT personnel can check into the problem, find a solution and deploy the solution with the safety of the transactions, of knowing the state of the art. If you want to know a bit more about the differences between OS3, the AB root strategy, NICs, there is this nice YouTube video. If you want to scan the QR code, it's by Justin Garrison. It's using a whiteboard to draw and explain stuff, very, very helpful. So I'm looking at the time and I'm going really fast. I didn't expect that. I was expecting to use at least 15 minutes more at this moment. So we are already at the questions because this is the general topic. We can deep into specific implementations, specific reasons. It's difficult to cover all the scenarios in one talk and can be really boring. I assure you, can be really, really boring. So if you have any question or use case or
So you mentioned several implementation examples like AB root, OS3, ButterFS. Can you talk about the use cases that each of those might be better preferred for, like maybe compare and contrast those so we can get a sense of where they would best be utilized?
Yes, sure. I believe is basically more a choice of the owner of the application or the system you're talking about. You should choose the strategy that fits more your specific need. The AB root strategy is quite simple. You have two copies of your core system and you switch between them. Your rollback point is the previous state and is only one state before. You don't have multiple states of your system. With OS3 instead, you have the Git-like management. So you can have as many restore points as you want. And you can have also different branches of your installation. ButterFS is more or less the same thing, let's say, to keep it simple. And again, you can have multiple points of rolling back. Those are not managed in a Git-like style. Those are really point in time of your installation that you can switch within. You don't have branches to move around. You have your main branch and you go up and down from that. And while you go up, you change your new branch. Once you go up, you can only go down, but you cannot go to the middle stage once you got back and go up again. So it all depends on your preferred strategy or needed strategy.
Does that imply that possibly the OS3 might be better if you're doing DevOps with Git?
DevOps with Git depends why. It all depends why. If you want to have multiple states in the same time, so concurrent multiple states available, probably yes. If your goal is to have always a safe point to restart your system, probably you don't need it.
So is there a difference if you're running infrastructure as code? Are some of these more command line programmable implementations, or are they all that way?
I'm not sure I got exactly what you mean.
So in DevOps, you have like things that are declarative, and you define everything through commands, and you can rerun those and get your state back up. Some environments have like a GUI configuration where you can't run it.
Keep in mind that every time you do a change, immutability implies a system reboot. So talking about DevOps, I don't believe rebooting in the middle of the process is something you like. Because usually you run an agent that runs an environment where things happen, but that's the environment. And for this topic, more than immutability, because usually you run a new instance of a container of this environment at every run of the CI, you would benefit of systems with recipes to define a state. So, or you run the system that can be using OS3 or whatever, and reach a state, you save that state to replicate, or you use a system like Nix to create a recipe of the system of the environment and always run it using that recipe. Maybe Nix is not thinking about CI where you create a new environment every time. Maybe Nix is not the best option because you are currently running through the full process. But for example, taking again Vanilla OS as an example, we have a recipe to create an image of Vanilla OS to a given state. And with that recipe, you can also bring into the system your tools needed for your CI. For example, if you have a particular build tool or you have a tool that is used to run your application or to test your application, you can include it into an image that will provide you a defined state, and you can run the agents with this defined state, being sure that it always runs in the same version, in the same state of the art, and provide you always the same result. So it's related to the immutability, but not directly, because what you want there is a reproducible system, not really an immutable system. Immutability helps you with the reproducibility because you have the controlled updates, but what helps you really in that environment is how you update. How are those updates installed? If you install with apt get whatever, this is not a real controlled environment because if there is an update of that package, or you always declare the exact version, or you will have different results. But if you use controlled atomic updates, then you can be sure that you are shipping always the same exact update to your system. And we have some cool feature in Vanilla OS for that. Thank you for your questions.
Hi. The examples you've given all require a reboot to activate
Yes.
the new image. Have you explored any options of testing the new image prior to rebooting into it? For example, by booting it in the container or even full virtualization prior to the reboot?
Not really. We talked about live patching, like you can live patch the kernel and other stuff. We didn't explore it too much, but we didn't really like it because of the consistency of the result. Booting your system from beginning in that version, you know that all the software, all the packages, requirements, systemd units are loaded in that exact version, in that exact order, and provide you a result. Testing it in a container, how would help directly the end user? I mean, you should switch the end user to that container. We are experimenting live migration of partitions. We are experimenting it. We have some issue of migrating the running processes. There are methods to do it, and we tested it, but we didn't completely succeed in doing it. Maybe it's something we are missing, and if anyone wants to help, it's welcome in the team. But it's not something we have been able to provide in a reliable way. Of course, would be awesome to provide it, but it must be reliable first. It can maybe be an experimental feature the user can enable, but then who are those users? Are more than enthusiasts, are users that know what's happening. Is not quite common.
Yeah, I think one challenge would be the data directory, which you mentioned, and having that data shared by two running instances seems like it could be problematic. So I guess if you wanted to do that, you'd need to use something like ButterFS to clone also the data as well as the base operating system.
Well, in Vanilla OS, we have subsystems. So the applications you are installing are not run on the host system, but are running in the primary subsystem that is actually Vanilla OS itself. It's a minimal container of Vanilla OS that runs your applications, but the updates are always installed in the host. You are not installing them in the container. So this complicates a bit the, the story behind it. But yeah, it is something we would like to provide. We are focusing, for example, in Vanilla OS, we implemented fsguard to verify the system at boot. And if it fails the check, you are in a minimal system that warns you about the problem and proposes you or to roll back or to continue anyway. We don't suggest to continue anyway if fsguard gave a red flag. So we are focusing on the reliability when you start your system. The startup of your system must be safe, and you must not be surprised of broken things. Thank you.
I was just wondering, you mentioned recipe on, you run the recipe and you build the base vanilla. I was wondering, when every change you have from your base system, is there an option to update that recipe? So I could, use the, so if there's a good state in, I was just wondering if they could update that recipe so I could run it on a different laptop, maybe.
Well, sticking to the examples of Vanilla OS, the recipe doesn't list the exact version of the packages or the state of the system. It defines what the Vanilla OS ISO must contain. So must contain Vanilla OS in its latest version, added of whatever you need. For example, the NVIDIA drivers. With the Vanilla Image Builder, we build the core image. We need the base desktop image. We build the NVIDIA image. So it's to provide you add-ons to the base system, and you can use it if you think about a company that standardizes what is installed on the laptops, on the servers, on whatever. You can use it to have a default output from the building of the image itself. Then, given the updates that we roll out, you have an updated system that is a reproducible system, because you are stuck in our updates. So you have an hash providing the state of your system, or you have a list of updates installed. But those updates, in our scenario, are released as OCI layers. It's a full layer containing all the data that is applied on your system. So given a number of layers, we can replicate your installation. So it's a mixture of all those topics. It's immutability with atomicity, with an update strategy that provides you a specific output that can be reproduced in different environments.
And so let's say you updated Python for something like that, and so vanilla would have that in some system that you update. Let's say I keep on updating multiple things. Is there any way? Is there a file where I could use that file to install, apply it to a different laptop?
Today, not really, but depending on the system you're using, this Python update you're installing can be installed in the host. So you create a transaction. For example, if we take Fedora Silverblue with OS 3, when you DNF update Python, this creates a transaction that will require you a reboot to have. If you install it in the host, you have a reboot. In Fedora, you have a toolbox that allows you to install stuff in the user space and don't require a reboot. And you have this in the toolbox. More or less the same thing happens in vanilla, where you don't install stuff like Python in the host system, otherwise this will create a transaction requiring you a reboot, but you install it in the subsystem. So with Apex, our utility to manage the subsystem, you update Python in your main container or a container you want to use for that specific reason. For example, you can have a subsystem dedicated to Python, a subsystem dedicated to Go, a subsystem dedicated to a different version of Python or Go. And also for those subsystems, you can create recipes that you can share between laptops and have the same installation. But again, this is a strategy of using it that is related to immutability, because we are talking about systems where you cannot write to your host, not directly, but are a different topic that you don't necessarily have only on immutable systems. This would work also on other systems using maybe other tools, or you can take Apex to a non-immutable system and have this management and have controlled environments that can be shared. So it's a linked topic, but doesn't involve immutability every time.
Thank you.
Thank you. We have a question there.
Yeah, can you please explain how you make sure the updates stay atomic? Vanilla?
When we start the process, we start it in a controlled environment, tracking the exit codes of each operation that is performed. And we wait the last moment to commit the changes on disk. So if any of the change or any of the commands, any of the apt update or command run through a software like a systemd do whatever, exits with a code different than 0, meaning error, we cancel the operation. And since we didn't write it to disk yet, we have a complete rollback of the operation. So leveraging the system, we are making the changes in memory, and we write to disk only in the last possible moment. That is not the last operation that is performed. It's halfway the process. I made a speech about this where there is a slide with the entire process and the state where you can still cancel it or not. On our website, we published the PDF of that presentation, I believe, if we didn't forget about it. But yeah, we do it in memory and write to disk at the last moment that we can wait to do it, because then we change the configuration of grub to say, okay, run the other partition, and we commit everything and tell to the user, ready to reboot. Reboot whenever you want, you will boot in the new updated system.
So is there a way to track that? So is there a way to track if you don't get all the exit codes and you're rolling back? Is there a way to track to figure out? Do you write any information to find out what is causing their issue?
You can get the output of AB root itself of the entire process and see where it blocked. Okay. We ask the output when we track issues and try to understand what's wrong. So the logs, we produce logs to know what happened. And in case you need help from us, we ask you to share some kind of log depending of what you're doing to better understand what happened on your system and figure out a solution for you. You're welcome.
Okay, I'm going to be a little closer to visceral experience here.
Okay.
Once upon a time when I was working with Sonos-based systems, Sonos at that time did what they referred to as big mama patches. This is not the way we do it anymore. Every little app wants to update itself. But this gigantic pile of patches that was all of the things. Oh, your mail system needs updating. Oh, your editor has a new version that does extra things. Oh, all of these things. So the mail system wanted to do an update and was no longer going to be compatible with the configuration file that it was fed, but everybody loves mail, right? So we obviously needed to roll back. Now, in the modern version of the world, but even more so in something like this, we would have a system in there that was in charge of editors and the things that the system needs. We would have maybe a user land for graphical that would be, that's X windowing and all of the things that a visually oriented user would use. And then we have the services. The web service would be one type of thing and all of its crazy little parts, and it's maybe another one that's its data set of what it's serving. And this mail system would go, I installed fine, sure, okay, we'd be on the B system. I mean, and we get calls like from the users like 20 minutes later, the mail stopped, put it back. So we would, in this case, we would put it back and we would be putting back all the other things as well. Is this true?
And you would like to know how to solve this problem?
Well, I know how we solved it then.
Okay. Well, this is another example. So I'm not sure the remote audience got everything from the mic, but it's about updating components that are bringing other updates all together with them. And when the component you updated, or maybe you're updating multiple components, one of the components is not working properly, and you do a rollback, but you roll back everything, not only that component. This is, did I recap it well? Okay. So, if I take as example what I just said about atomic updates, the atomic updates will not solve this issue, because if you ship an update that is a complete update with multiple components and the transaction doesn't exit properly, you have a complete rollback with nothing updated. If you update the components and you have a successful transaction, but then you find out that the service is running but isn't working, and you want to roll back, you still roll back the entire transaction. Or better, you go back in time with your installation. With OS3 will be a previous commit, with AB root will be the other partition, with Btrfs will be the other. So you are still at that problem. That problem is addressed containerizing each service or sandboxing each service, depends on the technology you prefer. You can use LCX, if I'm not wrong. So little systems running on your host system where you run usually only one service, so you update the single service, but it's an update strategy and is a system management strategy. Instead of having a system with multiple components that are indirectly interacting between them, you keep little systems or little containers with each service. Then you go to the point where you have more data due to duplication of dependencies, and there are strategies to address also that issue. But like the shared environments, this is not directly connected to immutability. Again, it's a linked topic that can help you in managing your system to have an easy rollback, because immutability in the end provides you an easy rollback to a previous state. But the real solution there is to manage the services in an isolated way. So with containers, sandboxes, microservices, that's probably the real only method to avoid that.
Stop making your web server live on your mail server. Thank you.
Or buy someone else's service, so it's their fault if anything doesn't work. Well, it's a strategy. Instead of self-hosting, pay someone else.
So many of us encountered a serial box that says, "Oh no, it broke, please call your system administrator."
Any other questions?
We have one there.
I'm a little bit confused about the ButterFS based one. How does an immutable system based on ButterFS differ from just like doing a normal like install of any distro on top of ButterFS and using like automatic snapshots or something like that?
It's basically how is controlled and decided by the system and how the system guides you through the process. With some solution, you need to know what you're doing and you need to know what your system is doing. In some solution, you could also don't know that your system is immutable. So it's basically about that. In, for example, Fedora Silverblue, but not only. Let's say that the distributions mentioned here usually hide this feature from you, user. Not because you don't have to access to it, but because you don't need to access to it. You don't need to perform operations on your own to leverage the advantage of those solutions. We distributions take care about it to provide you a safe system, a secure system, and you just enjoy it. Okay. You enjoy it in the flavor you prefer. It could be vanilla with Debian, with GNOME experience. It could be Fedora Silverblue with GNOME or KDE. It could be whatever you prefer. But you don't have to know how the immutability behind works.
Okay.
Then if you're a developer, probably will know about it because we'll have some specific need that will get you into looking into the immutability and how it works on your system. Otherwise, you don't need it. But as a developer, you will take advantage of Toolbox, for example, or of Apex. You will not need to know what is immutable and how it works. You will need to know how to use the specific tool on the specific system.
Okay. And kind of a related quick question. I know that like bcachefs is like the new addition to the kernel that's really similar in feature set to ButterFS. Do you know if there's anybody working on something similar on top of bcachefs?
I have no idea, I'm
No
sorry.
idea.
Thank you.
All right. If there's no other questions, thank you for all of your questions. And thank you, Pietro, for coming and giving us a talk.
Thank you.
And sharing.